Hello everyone, we're doing a worksheet on volume and surface area, and the questions are from paper P2 and they're from year 2019 and backwards. Alright, so let's jump on to the first question. So question number 1 is, the volume of a cuboid is 180 centimeter cube. The base of is a square of length 6. Calculate the height of the cuboid. So the formula for volume of a cuboid is length times width times height. So the volume is 180 and the base is a square with length 6, so length will be 6 and hence width will be 6 as well, and we have to find the height. So we'll enter 180 divided by 36 in our calculators and we'll get 5 centimeter as answer of question 1. Question 2, calculate the total surface area of this given cuboid. So let me redraw this. This has dimension 12, this is 5, and this is 7.5. So we need the total surface area. Total surface area is simply the area of all the surfaces. So let's find the area for the lower most rectangle and the uppermost rectangle. So it will be 2 times 12 times 5 because we have two rectangles of same size. Then let's find the rectangles at the right and the left. So area of the rectangle at the right and the left will be 2 times 5 times 7.5 plus area of the rectangle at the front and the back. So 2 times 12 times 7.5. So this should give 375. Question number 3. The diagram shows a cuboid with base area 7 centimeters square. So and the volume of the cuboid is 21. We know volume equals to base area times height, or length times width times height. So volume is 21, base area is 7, and we need to find height. So height is 3. Next we have to find the total surface area. So this dimension is 3. So similarly, just like the last question, we'll find areas of all the rectangles. 2 times 7 times 1 plus 2 times 7 times 3 plus 2 times 3 times 1. This should give us 62. Question number 4. Find the volume of a cylinder of radius 5 and height 8. Give the units of your answer. So volume of a cylinder is pi r square h. So pi, we have the radius which is 5 square and height is 8, and the unit will be centimeter cube. And let's see what we get. Pi times 25 times 8 is 628.3185 and so on. So correct to 3 significant figures. This is the answer. Okay, question 5. A cylinder has height 20, the area of the cross section is 74. So the area of cross section is simply the base area. So the base area is 74. Work out the volume of the cylinder. So volume's formula is either pi r square h or also base area times height for a prism. So volume we need to find. Base area we know is 74 times height we know is 20. So the answer is 1480. Question 6. A cylinder has height 12 and volume this. Calculate the radius of the base of the cylinder. So volume is pi r square h. Volume is 920 equals pi. We need the radius and we have the height 12. So divide 920 with 12 pi and then take under root to get the value of r. So under root fraction key 920 divided divided by 12 pi, 4.94. Part 7. A water pipeline in Australia is a cylinder with radius 0.65 meters and length 85 kilometers. Calculate the volume of water in the pipeline contains when it is full. Give your answer in cubic meters. Alright, so there's a unit conflict in the question. We have a pipe. Pipe is in the shape of a cylinder whose radius is 0.65 meters and length is, or height, length is the height, is 85 kilometers, which I'm changing into 85,000 meters. Okay, find the volume. Volume is pi r square times height. So this gives us pi times 0.65 square times 85,000. 112822.44 and so on. So this becomes 12300. No, 1 yes. No, I've rounded it off wrong. I have to round it off to 3 significant figures. So this becomes 113 and the remaining number before decimal becomes 0. Okay. Question 8. Which is a cone with height 14.8 and volume 275 centimeter cube. Calculate the radius of the cone. So volume of cone is 1 by 3 pi r square h and the volume is 275 equals 1 over 3 pi. We don't have the radius, but we have the height, which is 14.8. So make r the subject. 275 times 3 over 14.8 pi, and then take under root of this to get r. So under root, then fraction key 275 times 3, and in the denominator 14.8 times pi, which gives us 4.21, rounded off to 3 significant figures. Okay. Question 9. Calculate the volume of a hemisphere with radius 3.2. So hemisphere is simply half of the sphere. So volume of sphere is 4 over 3 pi r cube. Then the volume of hemisphere is 2 over 3 pi r cube. So do we have the radius? Yes, we do. That is 3.2 cube. So 2 over 3 pi times 3.2 cube, which gives 68.6, rounded off to 3 significant figures. Question 10. A sphere has volume 80. Calculate the radius of the sphere. So volume is 4 over 3 pi r cube. So 80 is equals to 4 over 3 pi. Radius we need to find r cube. Now make r the subject over 4 pi and cube root of this. So I'll write cube root, then fraction key, then 80 times 3 in the numerator and 4 shift pi in the denominator, which gives me 2.67, rounded off to 3 significant figures. Question 11. The diagram shows a hemisphere with diameter 5. So if diameter is 5, the radius is 5 over 2, which is 2.5. Calculate the volume. So volume of a hemisphere is 2 over 3 pi radius cube. So 2 over 3 times pi times 2.5 cube, which gives 32.7249 rounded off to 32.7, correct to 3 significant figures. Question 12. The diagram shows a solid pyramid on a square horizontal base ABCD. The diagonals AC and BD intersect at M. P is vertically above M. AB is 20 and PM is 8. Calculate the total surface area of this pyramid. So the surface area of a pyramid is, if I make the net, will be area of this square in between, then area of this triangle, this triangle, this triangle, and this triangle. All these triangles are equal in size, so I'll find area of one triangle and multiply it with 4. So in the center we have a square, so we'll write 20 square plus 4 times half into what is the base and what is the height of these triangles. So base is simply base is 20 and we need the value of height. Now how do we find these heights? Now notice here that this height is the slant height, the one I've drawn in blue over here, which is the same as this height, and this length is, that the whole length is 20, so half of it is 10. Now I can apply Pythagoras on 10 and 8 to get the blue line. So height will be 8 square plus 10 square under root. Which is under root 164. So we have the height. Now I'll substitute the value here. Half into base, which is 20, times height, which is under root 164. So this gives 420 square plus 4 times 0.5 times 20 into under root 164, which gives 912.249. So the rounded off answer will be 912 simply. Question number 13. Okay. The diagram shows a solid prism of length 15. Length is this length, which is also labeled 15. The cross section of the prism is a trapezium ABCD. The angle DAB and angle CAD are 90. Then we have a length 9, 4, 6 shown in the diagram. Calculate the total surface area of the prism. So total surface area is simply the area of all surfaces. So I see 2 trapeziums and I'll apply the formula half into height into sum of parallel sides. Then I see one rectangle at the left. This will be 4 times 15, and then I see one rectangle at the top, which will be 6 times 15, and then one rectangle at the bottom, 9 times 15, and then another slant rectangle which is 15 times this unknown value. So first we need to find this value, this red length, which is CB. So to find CB, what we'll do, we'll apply Pythagoras theorem. We know this length is 4, and we also know that this length will be 3. Why? Because all of it is 9 and then part of it is 6. So this would be 3. Applying Pythagoras theorem, I will get CB equals 4 square plus 3 square, which is 5. So CB equals 5. So this length is 5. Now I'll apply the formula for surface area, which is 2 times half into height into sum of parallel sides plus 5 times 15 plus 9 times 15 plus 6 times 15 and plus 4 times 15, and this sum would be 450. So total surface area is, sorry, 420, not 440 or whatever I said earlier, it's 420. Okay, question number 14, which says a solid consists of a metal cube with a hemisphere cut out of it. The length of the side of a cube is 7. The diameter of the hemisphere is 5. Calculate the volume of the solid. So volume of the solid will be volume of cuboid minus volume of hemisphere. So volume of cuboid will be 7 cube, length times length times length, minus volume of hemisphere will be, the formula for volume of hemisphere is 2 by, this is the volume for a sphere. For a hemisphere, divide this with 2, so this becomes 2 by 3 pi, radius is 2.5 cube, and our calculator will give us 310.275, and this, when rounded off to 3 significant figures, becomes 310. Okay. Next up is question 15, which is the diagram shows a toy. The shape of the toy is a cone, the radius 4 with radius 4 and height 9 on top of a hemisphere with radius 4. Calculate the volume of the toy. Give your answer in nearest centimeter cube. Alright, so total volume will be volume of cube, volume of cone plus volume of hemisphere. So volume of cone is 1 by 3 pi, radius is 4, r square, height, which is the vertical height, which is 9, plus volume of hemisphere is 2 by 3 pi, radius cube, which gives us 284.837 dot 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 dot, which is 285. Question 16, which is the diagram shows a cylindrical toy. The shape of a toy was a cylinder of radius 5 and height 8 on top of a hemisphere with radius 5. Calculate the volume of the toy. So again we have to find volume of cone plus volume of cylinder. So volume of cone is 1 by 3 pi r square, sorry, it wasn't a cone, it's a cylinder, and hemisphere. So volume of cylinder plus volume of hemisphere. So volume of cylinder is pi r square h plus volume of hemisphere is 2 by 3 pi r cube, and the calculator gives us 890.1179, and rounded off answer correct to 3 significant figures is simply 890. Question number 17, which is the diagram shows a glass in the shape of a cone for drinking milk. The cone for a radius 6 centimeter and height 15 centimeter. A bottle of milk holds 2 liters. How many times can the glass be completely filled from the bottle? So we will be dividing 2 liters, or 2 liters is 2000 centimeter cube. So divide 2000 with volume of glass, which is volume of cone. So volume of cone will be 1 by 3 pi radius square times height. So what do we get? 1 over 3 times pi times 36 times 15. We get 565.4866. Next I'll do 2000 divided by answer key. 565.4866. So in my calculator I'll do 5000 divided by answer and I get 3.53. But the question is how many times can he fill the glass? So he can fill the glass 3 times only. So how many times can the glass be filled? It can be filled 3 times completely. Okay. Part B. Calculate the volume of the milk left in the bottle. So volume, or we have to subtract the two volumes. So 2000 no, in fact what we can do is we'll do 2000 minus, we got to fill the glass 3 times and the volume of the glass is 565.4866. So this gives 303.539. So rounded off answer is 303, correct to 3 significant figures. Okay, question 18. A solid cone has a base radius 4 and height 10. A mathematically similar cone is removed from the top as shown in the diagram. The volume of the cone, that is, alright, I just remembered this is from grade 9 syllabus. We haven't done the formula for volumes of similar figures, which is needed here. So we just will ignore this question in grade 8. Next is question number 19, which says a container is made from a cylinder and a cone, each of radius 5 centimeters. The height of the cylinder is 12 and the height of the cone is 4.8. The cylinder is filled completely with water. The container is then turned upside down as shown. Calculate the depth d. Alright. So first we need the volume of the water. So volume of water will be volume of cylinder from the first shape. So volume of cylinder is pi r square h, which gives us, I'll write this in the form of pi, 25 times 12 is 300 pi. So the volume is 300 pi. Now we need to find the depth. So we know that this height is 4.8 from here. And let's call this height, the remaining height, h. Let's call it h, alright. So we need to find the value of h and then we'll add 4.8 to get the depth. Now the volume remains the same. The amount of water in both the containers or both orientation of the containers is the same. So volume equals 300 pi is equals to volume of the cone. So 1 over 3 pi radius was 5 times h is 4.8 plus pi r square h, volume of the remaining cylinder which has water in it, pi r square, and we don't know the value of h and we need to make h the subject. So first subtract these values. 300 pi minus 1 over 3 pi 25 times 4.8 and then divide it with 25 pi to get the final answer. So this height comes out to be 10.4 and d will be 4.8 plus 10.4, which is 15.2. Okay. Question 20. Okay. The diagram shows a solid hemisphere. The total surface area of this hemisphere is 243 pi. The volume of the hemisphere is k pi. Find the value of k. Alright, so we are told that the total surface area of this hemisphere is 243 pi. So the total surface area includes the area of this circle plus area of this hemisphere, the upper region of the hemisphere. So total surface area will be, so 243 pi will be equals to area of the circle. Do we have any expression for the radius? No, we don't. So I'll just use equals to pi r square, which is the area of this circle, plus surface area of the whole of a football or a sphere is 4 pi r square. So half of it will be 2 pi r square, which combined makes 3 pi r square. So to make r the subject, we'll do 243 pi over 3 pi and then under root. 243 pi over 3 pi under root, which gives us radius equals 9. Okay, so the volume of, so now we know that this radius is 9. Next, volume is k pi. Find the value of k. So the formula for volume of a hemisphere is 2 by 3 pi radius cube. So 9 cube times 3 over 3 is 9 cube times 2 divided by 3 is 486. So this becomes 486 pi, and we know what 486 pi equals k pi from here. So k equals 486. Question number 21. The sphere of radius r fits exactly inside the cylinder of radius r and height 2r. Calculate the percentage of the cylinder occupied by the sphere. Alright, so we need the volume of sphere over volume of cylinder times 100%. Let's read the question. Calculate the percentage of cylinder occupied by the sphere. So yes, volume of the sphere over volume of the cylinder times 100. So in the numerator, I'll write volume of the sphere, which is 4 over 3 pi r cube. In the denominator, I'll write the formula for volume of cylinder, which is pi r square, h is 2r, times 100. So this becomes 4 over 3 pi r cube divided by 2 pi r cube times 100, which becomes 4 over 3 pi r cube times 1 over 2 pi r cube times 100. So r cube gets cancelled, pi and pi get cancelled. So this becomes 4 over 6 times 100, which gives 66.66%, which rounded off as 66.7. Okay. Question 22. The diagram shows a solid prism of length 15. The cross section of the prism is a semicircle with radius 4. Calculate the total surface area of the prism. So the total surface area is, it's a solid prism, so we have to include all sides. So this is 8 times 15 because the radius is 4. So we'll write 8 times 15 plus, I have two half circles which combined makes one complete circle of radius 4. So I'll write plus 4 pi r square plus pi r square. So pi times 4 square plus, now I'm left with this curve region, the area of this curved region. So think of it as a paper folded. So it's a bent paper. When I'll unbend it, I'll get a rectangle, right? Assume we're holding a paper like this, a partially rolled paper, and when you'll unfold it, you'll get a paper like this. Its length will still be 15, and what will be this length? This length, which is this length. This will be, the whole circle's length is 2 pi r. So half of it will be just pi r. So this is pi and radius is 4. So we'll add 4 pi to it, plus 4 pi times 15 because length times width. So wait, I did not divide it with 2. Wait. So the circumference is 2 pi r, we divide it with 2, so we get pi r, and pi r is, yes, pi 4, so we add to it pi 4 length times width. So this is 358.76. 359 is the rounded off answer, correct to 3 significant figures. Okay, next up is question 23. A pipe is completely full of water. The water flows through the pipe at a speed of 1.2 meters per second into a tank. The cross section of a pipe has an area 6 centimeters square. Calculate the number of liters of water flowing into the tank in 1 hour. Alright, so this question is related to volumes and also the topic rates. So we're told that there's a pipe is completely full of water. Okay. And we're told the water flows through the pipe at a speed of 1.2 meters per second. So the speed of water is 1.2 meters per second, and the cross section of the pipe has area 6 centimeters square. So a cross section means base area. This area is 6 centimeters square. Right. Calculate the number of liters of water flowing into the tank in 1 hour. So they're asking for the volume of the tank in 1 hour. So we know that in 1 second 1.2 meters per second flows through the tank. The water flows through the tank at a speed of 1.2 meters per second. So in 1 second, what will be the volume flowing through the tank? So in 1 second, 1.2 meters is being covered by the water. So 1.2 meters. Let's change this into centimeters because we have a unit conflict otherwise. So multiply this with 100. So we get 120 centimeters. Alright, so now the volume for 1 second will be base area times height, which is 120. So the volume will be 6 into 120 is 0, 2, 1 carry 720. So the volume will be 720 centimeter cubes in 1 second. So in 1 second the volume is 720 centimeter cube. Then calculate the number of liters that flows into the tank in 1 hour. 1 hour is 3600 seconds, and find the volume, and then later change it into liters. 720 into 3600 is 2592000 centimeter cube. For liters, divide this with 1000 and we get this answer, 252 liters. Okay. Question 24 is more or less the same. A pipe is full of water. Cross section of pipe is circle of radius 2.6. So we have a pipe whose radius is 2.6. The unit is centimeters. Okay. Water flows through the pipe into a tank at a speed of 12 centimeters per second. So the length covered by water is 12 centimeters in 1 second. So let's find the volume in 1 second now. Volume in 1 second will be base area, which is pi r square, times height, which is 12. So this would be pi times 2.6 square times 12 is 254.8459, etc. So this becomes this is the volume in 1 second. So in 1 second, volume is 254.8459 centimeter cube. Now we have to calculate the number of liters that flows into the tank in 1 hour, again in 3600 seconds. How much water is flowing? So answer times 3600, which gives us 917,445.5858 centimeter cube, divided with 1000, we get 917.445, which rounded off to 3 significant figures is simply 917. A water pipe has a question 25. A water pipe has a circular cross section of radius 7.5. So now the radius is 7.5 centimeters, and water flows through the pipe at the rate of 16 centimeters. So in 1 second, the water is covering a length of 16 centimeters in 1 second. Right. So we can find the volume in 1 second now. Volume in 1 second will be pi r square times height in 1 second, which will be pi times 7.5 square times 16, which is in 1 second volume is 2827.4333, etc. So we have to calculate the time taken for the, so time taken is x seconds for 1 liter of water to flow through the tank, and 1 liter is 1000 centimeter cube, because this was in centimeter cube. So multiply, we'll divide in fact 1000 with answer. We get time equals 0.3536. This is in seconds. I've made a mistake in copying the question. The radius was 0.75. So this is 0.75. This is also 0.75. So when I find the volume, I get 28.27, and then I cross multiply and I get 35.36 seconds. So this is the answer for the last question of this worksheet, question 25.